Hello, thanks for joining me today. We're going to talk about division, and this might end up being a little bit of a long recording because even though this is going to seem really simple, division is tricky. And there are ways of thinking about division that I think are more helpful and less helpful, or if there's different ways to think about division. If we can move between those ways, it's really helpful. The biggest connection is the one between the fraction bar, a over b, and division. A over b means divided by a divided by b. But it's also important to recognize that within a fraction, all fractions are just a multiplication problem. A divided by b is the same as a times the reciprocal of b, or a times 1 over b. And so if you can think of division in one of those ways, or can switch between them, it often will help you in kind of clarifying a division problem. Now, this first one, there's 2 points here. Number one is just the very mundane basic idea that when you're dividing, the same rules apply as for multiplication in regards to sign. So if you have an even number of negative numbers that are being divided, then the answer is positive. And if you have an odd number, the answer is negative. So we've got 2 numbers we're dividing, and they're both negative, and so the answer is going to be positive. And in my second example here, same thing. 2 negative numbers, the answer is going to be positive. We'll talk about how to do the division, but first we want to just recognize that when we're doing multiplication and division, we treat them as the kind of the same operation or the same type of operation, and the rules of signs apply. So, odd number of signs, the answer is negative. Even number of signs, the answer is positive. Okay, and once we've gotten that out of the way, we don't have to worry about signs anymore, and we can worry about how do you do this division. Now, this first one is not meant to be a difficult problem. Obviously, you know what 15 divided by 5 is. It's 3. You didn't even need your calculator for that, and that's the answer. But I think when you're doing the easy problems, it's a good idea just to think about the definition of division. 15 divided by 5 is the same as 15 times 1/5, or 15 over 5, and that's a fraction we can reduce. We divide the top by 5, and we divide the bottom by 5, and we get 3 over 1, which is 3. Okay, so these all kind of go together. These are all different ways of thinking about division. Now, I say all that to say this. -5 divided by -15. First of all, it's tricksy because we got those negatives, but if we think about the negatives first, 2 negatives equal positive, and we can just kind of set that aside. Now, 15 divided by 5 divided by 15. I almost did it myself. Time and again, students will tell me the answer to this one is also 3. Now, oftentimes it's not presented in opposition here, so you don't often have 15 divided by 5 and then 5 divided by 15. But if I just showed you 5 divided by 15, or maybe not you'll get this, but other people, if they just kind of take a real quick look at 5 divided by 15, oftentimes the answer will come back, it's 3. And that is not correct. And so it helps us to write this in a different way. So 5 divided by 15 is the same as 5 times 1 over 15. It's the same as 5 over 15. And then if we think about it as a fraction, we can think of it in terms of reducing a fraction in the same way that we did above. So we divide by 5, and we divide by 5. By 5 isn't very clear, but you get the idea. And you get 1 on top and 3 on the bottom. Now, be honest with yourself. Does that freak you out? Like, does this problem freak you out, or the seeing the answer as a fraction? Do you want to do it on the calculator? And what would happen if you did? What would happen if you did that on the calculator? You get 0.3 repeating, right? 0.3333. So calculator isn't going to help us very much here. It's best to be able to just kind of suck it up and do these as fractions, because that gives you the answer in the readily correct form. 1/3 is the right answer. And whereas if you did some other method of division, a calculator, for example, it would not come out as clear or easy. So come to terms with going back and forth between division and fractions. On this next one, I think you're going to find this is helpful. Let's deal with this problem in order. So we have 5 divided by -1/3 divided by 1 -1. First off, what do we talk about? The number of of negatives. We have 2 negatives and a positive. So there's an even number of negatives, which means the answer is going to be positive. And we can just ignore the negative signs from now on out. Now we know what the final answer is going to be. We can set that aside. Second, I think it's helpful to think about this. Dividing by 1 is the same as multiplying by 1. And dividing by -1 is the same as multiplying by -1. So times 1 divided by 1, the identity property applies. This is the identity property that says if you multiply or divide by 1, you get the same thing you started with. So that really saves us some time and energy, and we don't have to deal with that part of the problem, right? It's just divide by 1, it's just not going to change anything. Okay, so now we're left with 5 divided by 1/3. So what I did is I cleaned up or stripped away all the parts of the problem that were kind of distractions, right? The negative signs were a distraction. I can reason those out separately. The extraneous divided by 1, -1 is a distraction, and now it's just 5. In fact, I can write it down. 5 divided by 1/3. That's all that's left. And 5 divided by 1/3. Now, according to our rules of division, 5 divided by 1/3 could be written as 5 over 1/3. That's a little bit awkward. Or we could write it as 5 times 1 over 1/3. That's a little bit awkward. So here we need to cast our minds back to grade school when we were first doing fractions and kind of freaking out about it. The rule that says when you divide by a fraction, you multiply by the reciprocal. And we actually used the word a reciprocal a minute ago when I said divided by b is the same as times the reciprocal, which is 1 over b. Well, the reciprocal of 1 over 3 is 3, so 5 divided by 1/3 is the same as 5 times 3 over 1, which is the same as 5 times 3. 3 over 1 is 3. So 5 times 3 is 15, and a lot easier than it looked when the problem started. Okay, now think about that and kind of reconcile in your brain that this 5 divided by 1/3, 5 times 1 over 1/3, all of that means 5 times 3. So just recognize that. Now it's not helpful maybe to put fractions in the denominator like this, but it is helpful to recognize that divide by 1/3 is the same as times 3 over 1. Okay, let's move on. We want to speed things up here. I want to show you one really useful rule in multiplication and division. And what do we do first? Well, first of all, we need to recognize what's going on here. We've got 3 multiplications on top, -3 times -4 times -2, and then 3 things on the bottom, or 2 things on the bottom that are being multiplied together, -6 times -2, and then this division bar here, which is a fraction bar, but it means division. So we're multiplying and dividing 5 different numbers. Yeah, we're multiplying and dividing in different orders and ways and whatnot, but the number of operations doesn't matter so much as the number of terms or the number of negative terms. And in this case, there are 5 negative terms. 5 is an odd number, which means the answer is going to be negative. And since the answer is going to be negative, I can just ignore the signs from now on out. I don't have to worry about the signs. They're done with. Okay, now let's move on. I'm going to rewrite this, and you wouldn't necessarily rewrite it like this, but I'm going to rewrite this in, and here's the trick. Sometimes when you have a fraction with a bunch of multiplications in the numerator and the denominator, it's helpful to write out those multiplications in even more factored form rather than multiplying them all together, which we could do. We could just do 3 times 4 times 2 and be done with it. But I'm going to suggest do 3 times 4, which is 2 times 2 times the other 2, and 6 is 3 times 2, and then there's the other 2. And then I'm going to say this is kind of funny. I'm going to say times 1. Why? Well, it doesn't matter. If I say times 1, it doesn't change anything. And now I'm going to cross off the factors that are the same. So there's a factor of 3 in both the numerator and denominator. There's a factor of 2, and then there's a second factor of 2. And what I'm left with is a factor of 2 on top and a factor of 1 on the bottom, which is 2 over 1, which is 2. Now, a couple of things to remember. What we're doing is we're actually just dividing this out. Remember I said I could have, if I wanted to, I could have just multiplied them all together. 3 times 4 times 2, what is that? 24. And 6 times 2 is 12. And then however I want to simplify this, 24 divided by 12 is 2, or 24 twelfths reduced is 2 over 1, which is 2. Okay, so what did I do? Like that method I just showed you, what was going on here? Well, when I crossed off the 3's, I was dividing the top and the bottom by 3, and then I crossed off the 2's and the 2's again. So it just was dividing by 12 on top and dividing by 12 in the bottom, just one at a time. So divide by 3, then 2, then 2. That's 2 times 3 times 2 is 12. And so I was reducing the fraction before I had put together the numerator and the denominator, the multiplication. Okay, so that's a really useful way of thinking of division and reducing fractions. That's going to come back over and over again, so I just want to point that out to you. All right, and then finally, and I think this is the last one. Oh, no, there's one more. Okay, I want to show you this problem just because this one is kind of quirky, and I want to show you that sometimes it's better to think of a different way to approach this. This problem has a numerator and a denominator, and the rule says do everything in the numerator first and everything in the denominator second, and then you can deal with that division, and we're going to do that. Okay, but in the numerator, what's going on? Well, we have parentheses here, which mean take the negative 3/4 and minus 1/2 and do that first. So divide, add those together, and then multiply by the negative 12. Well, can you see that here, if I were to apply the distributive property, that would save me some trouble. I'll do it out in kind of in some steps here. So we have negative 12 times negative 3/4 plus negative 12 times negative 1/2. And I hope it doesn't bother you that I said times negative 1/2 instead of saying minus negative 12 times 1/2, which would have been fine also. Here's what happens. First of all, in each of these cases, we have negative 12 times a negative number, so negative times a negative is positive. So all the negatives go away. The answer is going to be positive. But then, second, we can follow those rules I showed you, and we can multiply 12 times 3, which is 36, and then divide by 4. Or we could do 12 divided by 4, which is 3 times 3 is 9. So multiplying those together, I end up with 9, no fraction, which is nice. And same thing here, 12 times 1/2, or half of 12 is 6. And so now I don't have any fractions in my numerator, which you have to admit -3/4 minus 1/2 was not going to be fun to try to deal with. But now it's easy. 9 plus 6 is 15, and so we can finish that off. And we just need to deal with the denominator. I'll deal with the denominator in a second color. And so notice that sometimes it's helpful to take a piece of the problem and just kind of do that part of the problem separately. And then you have to remember that where it was in the problem and put it all back. So now I'm going to take the denominator and I'm going to do that. So 5/9 divided by -10 is the same as 5/9 times 1/10, or -10, or -1/10. And since the two numbers, there's only one negative there, the answer is going to be negative. And then I could just multiply across, right? 5 -5/90 if I wanted to, but I could recognize that 10 has within it a 5 times a 2. And so if I cross off the 5s, I'm left with 1/2 times 9, which is 18. Okay, so -1/18. So I have 15 on top divided by -1/18 on the bottom. So now let's rewrite that problem as a division problem so we can see what's going on. That's 15 divided by -1/18. Well, divided by a fraction, you multiply by the reciprocal. And so it's just 15 times -18, which is some big number, right? I personally pull up my calculator to do the 15 times 18 part. And this brings up another point. The answer is 270, but there's that negative sign, so the final answer is going to be negative. I don't rely on my calculator to tell me if the answer is positive or negative. You can do that, but it's much easier to make a mistake in typing things in on the calculator and get the sign wrong than it is to just remember the rules and apply them ahead of time. So I don't recommend you use the calculator to tell you if the answer is positive or negative, but do use it to do, kind of awkward big calculations like that. All right, final problem. Whew. This is one last little trick of division that I wanted to show you that really does help you out. And the idea is this. Remember I said sometimes it's helpful just to factor the numerator and the denominator, so write out the factors so that you can see what was being multiplied, and you can cancel out the common factors. That would be great here, but we do have factors going on, but it's easier to see that we have a bunch of subtraction going on. -15r cubed minus 5r minus 25. And so there's a bunch of things being subtracted. It's not really easy to see what the factors are, what's being multiplied. But because the denominator, this only works for the denominator is one thing, we can kind of do like the distributive property with division instead of multiplication, and that's because multiplication and division are the same thing. So what I'm going to do is I'm going to distribute that -5. I'm dividing the whole thing by -5, so I'm going to just divide each piece by -5. So I'm going to make this into -15r cubed divided by -5 plus -5r divided by -5 plus negative 25 divided by negative 5. So that because the denominator is one thing, you can think of it, well, you could think of it like this, right? Divided by negative 5 is the same as times 1/5. So negative 1/5, negative 15, whoops, got the 1, negative 5r, negative 25. So what we're doing is we're just taking the negative 1/5 and distributing it to each term so that each one is getting multiplied by 1/5 or divided by negative 5. And then we'll just deal with them separately. And again, this only works if the denominator is one term, is one thing there. If it was like two things being added together, negative 5 plus r or something like that, then we wouldn't be able to do this. Okay, so negative 15r cubed divided by negative 5. Well, first of all, we look at the signs. Two negatives, so the answer is positive. 15 divided by 5 is 3r cubed. Now we'll do the second fraction, negative 5r divided by negative 5. Signs tell us that it's going to be positive. 5 divided by 5 is 1r. Last, negative 25 divided by negative 5. You know what the answer is. Positive 25 divided by 5 is 5. And that is the final answer. All right, thanks so much for watching. I hope this was helpful. Have a great day.